swirly top layers, leaky LCD screens, holy 3D prints, and upgrade woes. All this and more, Print Fix Friday, episode 38. Let's get into it. Hey guys, welcome back to Print Fix Friday, and if you love 3D printing, you love fails, and you love looking at fails so you can learn a little bit, make sure to leave a like and hit that subscribe button. This is the longest running weekly print fail fix series here on YouTube, and we greatly appreciate your support. We're gonna start off with a Prusa print that is, well, maybe a little hypnotic. Next, we're going to move into an FDM print with some weird lines, where I think the issue is not so much the printer, more the user. We then move into a Elegoo Saturn that unfortunately is drinking the forbidden milkshakes. After that, we've got holy 3D prints that are going to leave you saying, holy shit. We're then going to move into a FDM failure that is all extrusion based. If you're doing printer upgrades, that's a great one to take a look at. And finally, we are going to end off with a resin print that's got a lot of white residue on it and how you can stop that from happening. But you know what you can't stop happening? My segue to our sponsor, 3D Musketeers, as they click the skip button and says, "Ha! You're wrong, sucker!" If you are tired of failing, we understand that 3D printing is not the easiest thing on the planet. We know. We do it often. The pros here at 3D Musketeers can help you get from art to part as quickly as physically possible while spending, hopefully, not too much freaking money. We have over 40 years of combined experience helping people just like you make awesome every single day. And if you want to get your prints shown off in Time-Lapse Tuesday or Time-Lapse Thursday, where we go through and show off prints that we're doing, whether it's for ourselves or for clients, you can always send us prints, and we can toss them on the old time-lapse printer right behind me. But if you do want to support what we do here, you can head over to patreon.com/3dmusketeers and contribute as little as $1 per month to helping us create awesome content every single week. We appreciate any amount of support that you guys can give. Of course, you can also hit the join button right below this video, and it integrates directly into Google and all that jazz. But if you're not feeling especially generous, we understand not everyone's got some cash they can kick into that creator fund. A like and a subscribe goes a long way to helping us grow to our next goal, and we are almost there of 5,000 subscribers. It was a little over a year ago that we hit 1,000 subscribers, and now we're getting to 5,000, and it's pretty amazing. We wouldn't be there without your guys' support, so thank you so much for everything that you all have done into helping us make this awesome content multiple times a week. I love doing it. It's a lot of work, but I really, really love doing it. Thank you all so much. But enough of my diatribe. Let's get into fixing those fails. Prusa Mark III S Plus. Strange top layer finish. Prusa Slicer 0.2mm layer height. Speed default. Setting. Materials. PLA. Any ideas? This is the printer's 15th or 20th print. Let's take a look at this. Originally, I was of the assumption that this was a domed part and we were just seeing, layers stacking. But on further inspection, this is using Archimedean chords for its top and bottom layer, which is odd because it's a very, very uncommon one to use. Normally monotonic is what I would choose. Archimedean chords look like this, where the lines are just off of a central location. You can see on small parts too, you end up with a lot of odd geometry like you see. If you go back to your top infill pattern and bottom and change it to monotonic and reslice, you'll see that the printer does its best possible job to start one line and go all the way across without making any movements whatsoever. We can see that, it does all of its movements. It comes up through here, then down, across, then it gets nice and large. Literally, this entire top surface is one continuous line of plastic. Monotonic is going to give you that cleaner top layer look, and if this style isn't kind of suiting your needs, go ahead and look at using monotonic rather than Archimedean chords. This one caught me because I thought originally it was concentric, but it's not. It's Archimedean chords, and this is definitely not the third time I'm recording the answer to this question. What are these weird lines in my print? Let's take a look. yeah, we got some lines. Let's see what the comments say. Belts need tightening. Only had the printer for about a month. Okay. Belts are tight. What are you making? Soap dish. Yeah, I don't think it's either of those. I actually think, and I'd be curious, I think it's lighting. And this is a really dumb thing, but I'm fairly certain it's lighting. It is why white filament is a problem and why I am completely against pure white. Like, design white for printed solid, love it. But that pure titanium dioxide white, terrible color, and it shows problems, and that's because of the way that light interacts with the layers. This thing is lit top down. We can see that based on the shadow. When we come in here, I don't think this print is anywhere near as nasty as it looks. I think we've got a little bit of deviation, which is completely normal for a 3D printer, right? They're not CNC mills. They're not going to hit 2-micron accuracy. They just don't. When you're dealing with an FDM printer like this, if you're hitting 50 microns or 100 microns, you're doing okay when you're looking at like fast speed printing. So yeah, my best bet here is it's actually the lighting. The rest of this doesn't really yell at me and say, hey, I've got a different problem. Because when we look up here where the light's not really interacting with it too bad, we've got some lines, but I don't think it's an issue. Now, what I do see that the individual's not talking about is that they have way too much damn infill. Like, way too much damn infill. Seriously, cut that shit way back. You do not need anywhere near this much infill. But we're not seeing the infill lines connect to each other. So even though you have all of this infill, it's doing you quite literally zero good whatsoever because you can't do anything with it. There's no strength here because the lines don't connect to each other. I would look at increasing the extrusion width of your infill. We do about 110% on the Prusas, and that makes sure that your infill lines, even if you're running them fast, are gonna stay connected like this. But for a part like this, dude, you don't need anywhere near this much infill. It's a soap dish for a shower. It's not like you're gonna stand on it. If you're gonna stand on it, you wouldn't print it like this. You could go down to 20% or less, 15, hell, even 10% would probably be just fine. And this thing would still suffice for precisely what you need. I think that's really the bigger issue. I don't actually think the belts are all that big of a deal. So I'm gonna go with lighting. If you turn off the top-down light and light it from the front, I bet you're not gonna see that. And if that's the case, then it is this same reason that white filament sucks. It's just showing you issues that don't exactly exist. But we'll follow up and hopefully we can get an answer on this one because this one's a little bit difficult because it could be quite a few things, but I think it's an Occam's razor where the most obvious answer is the right one. And to me, the most obvious is the lighting is top down and that's the problem. Resin leaked into printer, Elegoo Saturn. F's in the chat. Everyone, F's in the chat right now. We got a problem here, Chief. Buddy, there is resin everywhere. And by the way, resin is toxic. You should know this by now. And resin is not only toxic to you, but it's toxic to printers. Golly. Yeah, these photos are pretty rough. Pretty rough. We've got resin all over this. You can see it in between the matrix system for the LEDs. That is not compatible with printing. All right, so what can we do here? Well, one, the first step to getting better is admitting that you have a problem. Most likely here the screen came up or somehow detached from the printer itself. That's really the only way that resin can get under the screen and drip into that matrix UV system. This can happen if you break your screen pretty hardcore, or if you have a leak in your vat and your screen isn't perfectly sealed to the printer itself. After looking at this photo, I think it is fixable, but is it worth it? The Elegoo Saturn, now replaced with the Elegoo Saturn 2, has come down in price so much that it's like a $400 or less printer at this point. Honestly, like from a business standpoint, that is going to be given to somebody who wants to deal with it. You're going to spend hours cleaning this thing out. And the nice thing is, alcohol plus electronics is actually totally fine. You can clean electronics and alcohol with the caveat that you must make sure it is completely dead. You don't want any excess charge in the capacitors. We got capacitors all along here. That's some sort of a choke, most likely, more capacitors. You want to make sure all of those are dead, and the best way to do that is to unplug the printer and turn it on. That should discharge all the capacitors on there, and then that will allow you to rinse this entire thing with alcohol. If you do want to clean this, you're getting some gloves, you're getting a screwdriver, you're pulling this whole thing apart, and you're washing all of it in isopropyl alcohol, and you're letting it dry for a couple of days minimum. That's why I sit here and say it might not be worth it. This sucks. Real sucks. And I agree with Mr. Catlet here. If any light is on the array, they'd want to clean that up as best as possible. The rest, they'd cure in place. Yeah, okay, you could do that, and it's probably going to be fine. And it looks like it's 4 screws per set of the matrices, which is interesting because I'm assuming this was what they used for the Mars 2 Pro, and then they just added more of them for the Saturn. That's actually pretty smart from a usage standpoint. But I do kind of have to agree, you could just do that and YOLO it. But if you want to do it right, because again, resin is toxic, we do want to make sure that we do it right. Resin is not going to generally adversely affect anything in terms of electronics as long as it is fully cured, as long as it's not like an exposed IC or something like that, right? Inside of printers like this, you're generally fine. The only times I'd be concerned is if you had a bunch of resin pooling on connectors where it might bridge that connection, because I don't really know how that works from liquid resin to non-liquid resin, and if that, like, I don't know, and I don't feel like testing it. But especially in these connectors and all that, make sure those are clean, but if you don't intend to reuse them, then screw it, it doesn't really matter, I guess. But I would clean the whole thing. Chris Catlett says don't bother. I see both sides of the story, but definitely want to make sure that you clean those lenses, and that's really simple. 4 screws per lens array, take it out, put it into a clean vat of alcohol, or spray it with clean alcohol, or whatever you want to do. But those lenses need to be very clean, or you're going to impede the flow of the UV light, basically giving you dull spots in your printer. F's in the chat for sure on this one. Thankfully, it's repairable, and it appears that nobody got hurt, and that's always, you know, the best outcome for an instance like this. Help, please. Perfect circular holes in my minis. On some areas of my build plate, I began to have some random perfect circular holes in my prints and wraps. I honestly don't know why. I know why. I use an Anycubic photon printer. It's not a resin problem because I've used 2 different kinds of resin, and I've encountered the same problem. Can somebody help me, please? Yep. Your screen's dead. Absolutely, that's what the problem is. Now, interestingly, the hole starts small and gets larger. I don't know why, but yeah, it's generally the screen. Let's see what they're saying. Yep, confirmed. They've got a lot of circles. Is there a way to fix it? Nope. You got to replace the screen. And on these older Anycubic photons, because the photon is as old as my OG Marses, they're LCD printers. You can technically replace the screen if you want, but for the cost of a newer monochromatic LCD screen printer, that's what I would go with, because you're going from layer times from 8 to 13 seconds all the way down to like 2 to 2.5 seconds, which is insane when you look at print times and how much faster you finish something, right? That's like going from an Ender 3 to a Bamboo Labs X1 Carbon, which no, we're not getting one in, unfortunately. I reached out but never heard anything back, so bummer. If you do want us to review it and take a look at it, hit up Bamboo Labs. Give me a hand here, because I don't think they got my latest emails. But yeah, replacement screens are no problem at all. Also, for this mini, look at printing it at an angle. We can see that the base all appears to be printed dead flat. Look at angling the part back a little bit. That will reduce your peel forces and likely give you a little bit nicer of a print. Otherwise, yeah, just get a new screen. Also, if you are dealing with resin printer problems and you think it might be related to exposure, take a look at the Table Flip Foundry Cones of Calibration test print. It doesn't take all that long at all to print, and quite frankly, it's a pretty nice print. And they're really easy to understand, give you an idea of what success and failure looks like from the perspective of 3D printing. And if you want to hear more about that, tune in this weekend, Sunday, noon Eastern, where I'm going to be hanging out with Ty, the creator of Table Flip Foundry and the Cones of Calibration. You might say he's the architect, if you will.
It's about the cones.
But yeah, that test print is amazing for getting your resin printer exposure dialed in perfectly. Bad top layer surface. See comment. Okay, what do we got here? All right, printers. I think the problem appeared when I installed the BMG extruder. It could. I calibrated the E-step a lot of time since I installed it, and it always looked like the top surface is over extruding. My measurement says the E-steps is 430, but I lowered it to 400. Info. Ender 3 with silent mod, BMG extruder, 400mm E-step, 0.4 nozzle, 0.2 layer height, 50mm per second speed. Overture ABS black, 240C on the hot end, 10C on the bed, 40C on the enclosure, which means it's probably a non-heated enclosure. Possible errors. Nozzle, maybe, probably not. E-steps, most likely. Over thigh extruder. Enclosure too hot. No, it's ABS. ABS loves heat. Aliens. Aliens. I'm going with aliens. We got someone else saying that they've usually around 415 with their BMG, depends on the filament, but they want to say they're set to 413 and they adjust the flow in the slicer for different filaments than the one they use for calibration. Yeah, it actually looks like a lot of people are saying 415 for this, but I am kind of curious, right? We are absolutely over extruding and we've got a fun little problem. Not only are we over extruding, but I also think we're printing either too fast or we're moving too quickly or our acceleration is too high. So we've got blobs at the end of every line where the printer goes to make a move. This is from back pressure. I know this because I've dealt with it a ton on one of our large Bowden 3D printers that has a 30-inch long Bowden tube. Yeah, it sucks. To the point where the only way to solve the back pressure problem was to either slow the printer way down, which I'm not going to do on a $5,000 3D printer. It should be able to run fast. Or just go up in nozzle diameter and run it at 0.6, which is what I do, and it works just fine. Actually, it prints way happier at 0.6. We can see that we're definitely over extruding, right? We can see it even on the perimeters themselves. We've got overlap, but it looks like there's a peak in between each line, right? If your ruffles have ridges, that means you're over extruding, especially when you're dealing with, you know, top layers. I want you to take a look at other top layers, like not the top layer, but other solid layers, to see if it looks like this as well. Normally speaking, your top layer is done quite a bit slower, as well as a reduced amount of flow to give you that clean look. But the other thing to note here is that this is going to be very, very difficult to print on an FDM printer. Like, really difficult to print on an FDM printer. I don't feel too bad that it doesn't look amazing, but I do believe you have a back pressure problem that could be caused from over extruding. If you are running too fast, which I don't think you are, if you're not running hot enough, which again, I don't think you are, 240C should be fine for ABS. Both of those would cause back pressure. The other thing you can look at is how fast you are detracting your filament. That is putting it back into the nozzle when you do a retract. You want to rip the filament out of the hot end as quickly as physically possible. You know, 40 to 60 millimeters per second is totally fine to pull it out. But when you're putting it back into the nozzle, the de-retraction, you want to go relatively slow. I would not go above 30 millimeters per second, and that is to help equalize the pressure as you have to neck that filament down to get to the nozzle orifice. Remember, nozzles have a very tiny orifice, 0.4 millimeters. And actually, earlier this week, we looked at a diamond nozzle, and I have some pretty cool macro photos where you can see how tiny nozzle orifices actually are. Orifices? Orify? And yeah, even after the glass scratch test, by the way, the thing still looks perfect. And you can see that hole is really, really tiny. And if you're trying to force filament into that really quickly with high acceleration and high de-retraction speeds, you're going to create back pressure that will bite you in the ass when you do go to slow back down. High back pressure can also basically show up as what could be over extrusion. But because everyone else is saying that 415 is where you want to be for a BMG, I would try that as well. Because realize going from 430 to 400 isn't even a 10% reduction. So that's not as much as you might think. And generally speaking, you can be 2 or 3% over or under and not really notice a big deal when it comes to extrusion. But 10, 15, 20% over, yeah, you're going to start to notice under or over extrusion in those numbers. New to resin printing, what can I do to improve my prints? Yep, been there. All right, let's take a look. So 1, stop using Chi2 box and go use Lychee Slicer. That's the first thing. And if you want to learn more about Lychee Slicer, we have an entire playlist that also includes a podcast where we interviewed 2 of the team members from Lychee Slicer. They talk all about the software as well as tons of random things. It was a fun one. We'll cart that so you guys can take a look. But yeah, get the hell out of Chi2 box. It's a terrible software. Exposure time of 6 seconds. Depends on the printer. Do we get told the printer? Okay, it's an LD002H. The other thing to note here is that it is a monochromatic screen. It means the 6-second exposure time is way too high. You're gonna want to run the cones calibration so you can get those figured out. With a monochrome, you're probably gonna be somewhere in like the 2.5 second range, somewhere in that general vicinity is where most people end up. And I would add a second of light off delay. It helps get the resin into the areas of the print before it exposes the next layer. But yeah, this is a cleaning thing. So you got to make sure that you clean your resin prints well. This white material is from improperly washing and improperly curing it. This is exactly right. It is leftover residue from when you washed it and then cured it onto the model. They recommend a wash in dirty IPA right after it comes off the printer, followed by a wash in clean IPA, and then letting it dry completely before a final cure. I absolutely agree. I like the 2-bucket method, whether it's washing a car or washing your resin prints. Have a dirty bucket and a clean bucket. It's worth it. And even to the point where I'm starting to mess around with using alcohol in a spray bottle, which, by the way, if you don't have good ventilation, do not do that. Alcohol really upsets your lungs. That is a means to get the dirty resin off of your part, right? I'm using clean alcohol. I have a bucket under it, spraying alcohol, letting that resin drip off, and then it goes into clean alcohol to get any of the extra little bits the spray didn't hit. But a dirty and clean solution works out great. Personally, we don't do a lot of cleaning with alcohol. We are using Mean Green, which is a floor cleaner of sorts. It's a universal cleaner. And one of the things that I love about Mean Green that you don't get with IPA is that resin falls out of solution. And so you can easily funnel off that uncured resin from the clean Mean Green fluid. That's what I happen to quite like about it. However, it does not clean as well as alcohol does. So a lot of times we'll put it in the Mean Green, we'll take it out, we'll let it fully dry, and then we'll do just a quick dunk into a clean alcohol tank just to make sure that everything is happy. But yeah, this is all going to be about your washing, drying, and curing process. If you cure your model before it is fully dry, you're generally going to get these spots on it, and it is just leftover residue. And the funny thing is that there's really no easy way to get resin parts completely clean. What you get is that the thin layer of liquid resin that's still on there, of course, resin is toxic, it will just dry, and then you cure it, and it's not that big of a deal. For something like big models where you need lots of fine detail, yeah, you're gonna wanna make sure you clean it for a long time in very clean alcohol. And this poster has a good point that doing a heated dry is a great way to do things. And Uncle Jesse has talked about this before, and I'm sure other YouTubers have as well. We'll cart to Uncle Jesse's video so you guys can take a look. But he talks about using a heat gun to help get your supports off because it makes the resin flexible before you do your final cure. And I have to agree. You let it air dry. We normally like to let the stuff air dry for at least 24 hours before we're pulling any support material off. However, if you need to do it faster, you can always use a heat gun to speed that process up. And I do appreciate the hell out of this. PSA, do not put any uncured resin down the sink. That's right, because resin is toxic. Set it in the sun for an extended time and evaporate as much of it as you can and throw the rest in the trash. Maybe I would make sure it's fully dry before you do that. Like when we go through all of our raw resin, I will filter it through quite a few filters to get some of the big particulate out. Then I will let it settle and I will then pump it out. But alcohol, the raw resin stays in suspension. It basically turns it into jello where it gets jiggly, and there's really no good, safe ways to get clean alcohol out of it. You can distill it, but it is a little dangerous to do that, especially inside of a home. Please don't do that. But yes, sanitary sewage treatment cannot handle the compounds in resin, and it ends up piling up and polluting the systems. Yeah, this is absolutely true. Please, 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 please pay attention to that. But yeah, guys, that's all I got for you today on this episode of Print Fix Friday. Let me know down below if there are any extra fails you guys want to see. Remember, you can always tag us on the social medias as well as use the hashtag PrintFix to get our attention so that we can add your fails into this next episode. Let me know your thoughts. I'd love to get your input on this. But stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Jello, where it gets jiggly. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters. Remember, it is the first week of the month, and that means it is the perfect time to support the creators of your choice over on Patreon. Patreon charges you the first of every month, and we at 3D Musketeers have tiers starting as low as $1. And if you want to get your name in these credits, that's scrolling right next to me. The $5 tier and higher grants you that permission. But right below me will be the entire Print Fix Friday series, and next to that will be our series all about resin 3D printing, because we are definitely talking more about resin fails. I will see you all down in those comments, and in the next one, don't forget to like and subscribe. Take care.